Alright, this is your lesson today on quadratic functions. Okay, the guiding questions. These are the questions you should be able to answer when you're done. What is the standard form for a quadratic function? Is the vertex of a parabola its minimum or maximum value? How do you write quadratic functions in standard form? How do you complete the square? What are the two ways to find the vertex of a parabola? Alright, let's get started here. A quadratic function is one that looks like this, meaning that the highest exponent is a 2. Okay, this is an example. X squared plus 2x minus 8, where the highest exponent is a 2, it's a squared, that makes it a quadratic function. Here's another one. It doesn't have to have anything after it, or it could have something after it, but as long as the biggest exponent on the x value is a 2, that's what makes it a quadratic. This is the standard form, or vertex form, sometimes we call this. Or you can read that right off here. And the vertex would be h, comma, k. Notice the minus here and the plus here, okay? So this is the vertex form or standard form of a parabola. You have an a function out here, an a value, the coefficient. The a tells you whether it's going to be stretched or shrunken vertically. Are you going to stretch it or compress it? Okay, and whether a is positive or negative, you can also know that whether it's opening up or down. So here's my standard form for a quadratic function or a parabola, and if a is positive, then the parabola opens up. If you're positive, it opens up like a happy face, and if a is negative, then it opens down like a sad face. Negative, down, positive, happy, up. Okay, so when you take the absolute value of a and it's more than 1, it's going to be a vertical stretch. If the absolute value of this number in front is smaller than 1, then it's going to be a vertical shrink. So it's going to look wider. So if it's greater than 1, it's going to look narrower. If it's less than 1, it's going to look wider. So how do you find the minimum or maximum value of a parabola? Well, the minimum and maximum is going to be at the vertex, the very highest point or the very lowest point. In this case, you see how it looks like a sad face, so it's opening down. So when it's opening down, the vertex is going to be at the maximum. Okay, the minimum or maximum of a parabola is at the vertex, which is on the axis of symmetry. Axis of symmetry would be this line here. The axis of symmetry is where it's the same on both sides. Okay, it's the same over here and over here, over here, and over here. So that's axis of symmetry. And because the axis of symmetry is a line, it has an equation. In this case, it's x is equal to 2, would be this line right here, the axis of symmetry. So we're going to identify the vertex. So here's a quadratic function. You notice the highest exponent is 2, and we're going to find the vertex. We're going to write this in vertex form. So I wanted to make it look like what we had before, like this, vertex form. So how do we do that? You may remember from algebra, okay, algebra 1, you complete the square. Alright, you never can complete the square when there's a number in front of your x squared term, so you're going to have to factor that out. I'm going to factor out a 2 out of the 2 and 8. I'm going to leave the 7 by itself because that's not going to be part of my square anyway, so I don't really have to worry about that at the moment. So when I factor out a 2 from the 2 and 8, I get a 1x squared plus 4x. Now what do I put here? That number is going to be 4. We're going to take half of the middle term, the b term. This is a, b, and c. The b term, we take half of b and we square it. We put that in here. Half of 2 is 2. 2 squared is 4. Now, we can't just go around adding numbers to my equation. We actually added 4 here, but since it's in the parentheses with a 2, we actually add an 8. So we have to take away an 8. Take away an 8 from the 7, okay? That's why I didn't bother with factoring out a 2 here. We would have got a fraction, and I don't want to do that. Alright, so now simplifying this, because we took half of 4, that gave me the 2. When we squared the 2, we added the 4 here, And when we added 4, we have to subtract an 8 because we put it inside the parentheses with a 2. 7 plus a negative 8 gives me a negative 1. Now we have it in vertex form. Now what is h and k? Well, h is going to be a negative 2 because this was a minus here, and k is just going to be the negative 1. So that's how you find the vertex. There's another way to find the vertex, is to use the axis of symmetry. There's an equation for the axis of symmetry. In this case, it's going to be x is always equal to something. Okay, in this class, x is equal to something. So now we're going to have b, which is 8, over 2 times a, which is 2, and it's negative. We have a negative here. Negative b over 2a. Okay, that's a formula that you need to write down for the axis of symmetry, and you had a formula for the vertex form. So putting the 8 and the 2 here, we get 8, negative 8 over 2 times a, which is 2. So 8 over 4, right, which is just negative 2. So that's how we get x, this x here, which is h. This is my axis of symmetry, and that was going to give me the h. Now how do you think you get k? All you have to do is put it back in here. Okay, put the 2 back in here. 2 negative 2 squared is positive 4, times 2 is 8. 8 plus 8 times negative 2 plus 7, right? And you're going to end up with negative 1. See how negative 1? Got the negative 1 here. You could have completed the square, or you could use the axis of symmetry formula. Okay, both ways will give you a negative 2, comma 1. Negative 2, comma negative 1. All right, so I'll let you try this one on your own. You should pause it. When you finish it, you'll see the answer down here. Okay? All right, so you're going to do the same thing as we did, and then you should end up with this, and the vertex is at 2, comma 14. You notice there's a minus 2 here, but the vertex is actually positive 2, positive 14, because the negative is in the formula. Okay, here's another one. You may want to try that one. Pause it here. Make sure you can do at least one on your own, and hopefully it will be this one. All right. When you're ready, you can play it and you can see the answer. All right. So I got negative 4, comma 4 is my vertex. Okay, finding the x-intercepts. There may be 1 or 2 depending on where the parabola is. So here we have the quadratic formula or quadratic equation, and notice when I said that you can't have anything in front of my x squared, there's a minus sign here, or a negative, so we have to factor that out. So we factor out that negative, that makes this 6 negative. So it's the 6x is now negative, because when we distribute this negative sign, we're going to get negative x squared minus 6x. Leave the negative 8 alone. So see if you can finish this, right? Pause it and see if you can finish this completing the square, in case you were not very successful with the last 2. Okay, so I know that I want half of negative 6. Negative 6 is negative 3. Half of negative 6 is negative 3. Squared is 9. And remember, when we put this in here, we actually added a negative 9. That means we have to add a positive 9 to the other end. Okay, now simplifying this, half of negative 6 is negative 3 squared. That's how I got the 9. So this is negative x minus 3 squared. Negative 8 plus 9 is 1. So when we were trying to find the x-intercepts, we want to make y 0. So we want to make y 0, put a 0 on this side, and solve for x. Subtract the 1 from both sides. Divide by negative 1, or actually I move this over on this side, right? And got a positive. And then take the square root of this square. Now be very careful when you take the square root of a square, you get a plus or minus. Okay, when you cancel this out, you get a plus or minus 1. Square root of 1 is 1, but when you take the square root of a square, plus or minus, don't forget the minus. Sometimes we take the square root of 1 and go, oh, we got 1. But that's not the only answer. There's 2 answers here. So 1, you're going to write this as x minus 3 equals positive 1. Then you rewrite it again, x minus 3 is equal to the negative 1. How do we finish solving this? Add 3, and then we get 2 x-intercepts. One at 4, comma 0, and one at 2, comma 0, because we made the y 0 over here. Okay. Okay. Now here's one for you to try. Pause this. When you're done, come and check your work. Okay? So doing the same thing as I did before, I end up with this by completing the square, and I get solving, putting f of x is equal to 0 or y is equal to 0. I solve, I got a 2 and a negative 7. Alright, one last thing I want to do here is if I give you the vertex h and k and it passes through 3, negative 6, that's x and y. First, when I write it in vertex form, I have h, k, x, and y. So we have everything here except for the a. So all we have to do is solve for the a. So writing in vertex form, I put the 1 and the 2 here for h and k, and I also put 3 and the negative 6 for y and x. And then we just simplify, right? 3 minus 1 is 2, 2 squared is 4, so we get 4a plus 2, subtract the 2 from both sides, negative 8, divide by 4, get negative 2 is a, and we're done. We put that negative 2 back in here, use the h and k. Do not use 3 and the negative 6 because there's lots of points on my parabola. This is just one of the points. The important parts are the vertex and the a value. Okay, remember that this opens down. Alright, here's one. Try that one on your own. Okay, and I got this, where a is 1 and negative 4 and 11 is my vertex.